said, we're going to jump straight into Ayden's part. Ayden's going to walk through again some of the demos that they're doing, some of the work that they're doing, use cases that they're using with this to show you some of those live in WebFOCUS, and excited to hear about that, including how they're using NLQ to enable that inside their business. So Ayden, with that being said, let me stop sharing. I will pass this to you.
Perfect. So, I've been on a few of these before with maybe this audience. You've seen my face here. We'll do things a little bit differently today. I've got a few demos on really the latest and greatest in WebFOCUS 9.3.4. So a lot of sort of high emphasis on some of the new functionality. I'm going to cover ML Functions, which is our no-code model training tool, but I'm really going to focus on that from the operational side. So how do we, figure out a problem, a predictive problem we want to answer, and then turn that into a consumable dashboard, right? Walking through that step of start to finish, how do we then present those insights in a way that's, consumable and available to decision makers. So if you're more interested in the nitty-gritty of the details on how the model training happens or even the installation process, we've covered that in the past. There's lots of good information there, but really the focus of this one will be on the operational side. We'll also be talking about NLQ, right? That's natural language querying. That's the ability to sort of in a way similar to the Gen AI that people are getting used to, the chat GPTs, ask a plain English question of your data and then get back an answer in the form of a report or even a visualization, right? And that's great for ad hoc analysis. It's also great for, in this case, we're talking about embedding that into a broader dashboard and giving the end user the ability to then, ask further questions, make their own visualizations, essentially using natural language, right? Just interacting with their data in plain English. Okay, going to share my screen here. Perfect. Okay, so we're starting. Yeah, awesome. So we're starting a little bit backwards. We're looking at the end result, a dashboard that's making use of a churn prediction model, right? So this is something where we're exploring our banking customers in this case, looking at who's at risk, what the properties of their account are, what some of their demographic properties are. And this is sort of a sneak peek of what we're going to get to. But first, we got to go back and look at, how we're creating this predictive model. In this case, again, predicting risk of customers at risk of churn. And we'll work backwards, see how do we train that model, how do we apply that to a new data set, and then we'll continue from there. So what I've done is I've gone into the data flow view. If you're familiar with the new data migrator interface, maybe this sort of looks familiar. Within this, I can do my statistical modeling. I can do sort of my merging of data sets, a bunch of functions like that. But on top of that, once I do have DSML installed, I'm given this additional tab. You can see on the left, the train models and the run models tabs. So within the data flow view, these are giving me the ability to ask a kind of question, a predictive question, and then assign that to a model. So all I really need to know is what's the difference between these different models. And once I know what problem or what category my problem fits into, I can just, get started training it. So we look at binary classification, right? These aren't individual models. These are categories of questions that I'm looking to answer. That would be the one we're working with now, binary classification. We want to assign a at-risk or okay label to every customer, right? That could be multi-class too, though. It could be assigning customers to different categories across more than two fields. Regression, right? That would be with a numeric measure. That could be something like the percentage likelihood a customer is to accept an offer. Clustering, that's unsupervised, so that's just automatically happening. It's a great way to group, customers, branches, warehouses into categories or groups based off of the latent characteristics of their individual units of an individual customer of an individual location. And again, that's done without input from the end user. That's really useful for stuff like white space analysis. To sort of explore farther how your customers are divided, how your entities are divided, and do that in an unsupervised way. Same thing with anomaly detection, right? We're talking fraud detection, a lot of predictive maintenance use cases. Really, I just need to know what kind of problem I'm looking to answer and what category that falls into. So again, in this case, we're going to do binary classification because we have previously churned customers. We're looking at creating a model that can then predict whether or not a customer is at risk of churn in the future, right? As we get new customers, we want to be able to assign that label. So we can see we've selected risk as our target. The positive class is churned in this case. This is just asking us within our data, what column do we want to predict? In this case, it's the risk column. So that's what we're predicting. And within that risk column, there's either churned or okay. Because again, we're giving it historical data for its initial training. And once we've done that, we'll be applying it to new customers that don't have any risk label, right? The only other thing I can do here is deselect manually or select individual columns I want the model to consider. When it comes to what's important for that prediction, the model will determine that automatically. It'll figure out what's useful, what has predictive power. But if I do want to exclude something, in this case, I excluded customer ID, maybe there's sensitive information, I can manually sort of choose which columns the model sees when it goes to run its prediction. So now that I've done that, I've configured that module. You can see its binary classification there. I'm going to press play to run this flow. And what that's going to do is train the model. Once that's done training, it'll give me an output of all the different accuracies and model performance once it's been trained. Again, this is done with the sort of scale that WebFOCUS normally works at in mind. So you can see it's very quickly there. This is a smaller data set, but it is used to that enterprise scale of data. These are relatively lightweight. It's also running a bunch of these in parallel under the hood, right? If you've heard of something like a neural network or a random forest model, that's a simpler one, or even just something simple like logistic regression. Those are individual algorithms that it's running in parallel, right? So it's running all 5 of these in parallel and then giving us the performance based off of our question, right? So we can see here AUC, that's similar to accuracy. We're looking for the one with the highest score. In this case, extreme gradient boosting on the bottom left there has like a 92% accuracy. But if I want to pick a different model for another reason, I can do that. If I don't understand this, it's going to automatically pick the best one for me as well. But again, we can see here the gradient boosting is done the best. We're going to save that model. It's saved as a master file in a way that I can share, I can make use of for further analysis. I can configure the title, description, everything like that. I've just saved it there for later to then use against new data and apply against new data. But before we do that, we can also look at the model itself, how it's performed, get some sort of analysis of how the model's coming up with its predictions. When we fed it our initial data set, 20% of that was reserved to test the model's accuracy, right? So 20% of this, the model never saw when it trained, and now it's being used to determine how well the model did. So you can see here, this is the top of that test set. Most of them, these are getting correct, right? These were okay customers. It predicted as okay. When it got correct is churned, but you can see on the top there, there's a false negative, right? It predicted as okay, but they were actually churned. So we can take a look at the model's results just off of this initial data set. Again, we can see there's a couple other churned customers it's missing. But this is just a great way to sort of explore how your model is interacting with the data. On the right here too, we have a slider between recall and precision. Those are slightly technical terms, but essentially I have the ability to dynamically choose whether I want to favor false positives or false negatives, right? So whether I want to err on the side of sort of caution and be conservative is what I label as at risk in this case, or if I really want to make sure everybody that's potentially at risk is being labeled as at risk. And, an extreme example where this would be really important is like medical applications, where maybe I'm screening people for some farther tests. I really don't want to miss anybody. I want to make sure everybody that potentially would need a follow-up, gets that label. So I'd be favoring recall more than I'd be favoring precision in that case. And again, by default, it's picking whatever gives the best model performance. But if I was to dynamically adjust that, and I can do that before I save the model, it's going to adjust all of these performance metrics accordingly. So I might be sacrificing a bit of accuracy to then make sure I capture everybody, or to make sure I'm, the people I do capture, I'm 100% sure they're at risk, right? In this case, maybe I'm doing follow-up and I want to do something, that's really involved, and I only want to be doing it to our top customers that we are 100% sure are at risk. In this case, though, we're just going to leave it as the default optimal threshold for model performance. Another really important tab, there's so many more that I'm not covering, but this one's really good to understand the model better, is feature importances. So this is saying of all the columns that were fed into the model, which ones have the most impact, which ones made the most difference in determining whether somebody was at risk of churn or not. Some of these make sense, right? The months they've been inactive, if they've had like a decrease in their last quarter balance change, even just their current balance and utilization, those are all really important in determining whether or not somebody's at risk, right? Stuff like these more demographic measures like their age or their education maybe have less of an impact. So this is telling us again how that model is coming up with its predictions. So I'm gonna exit out of this now. We've trained our model. That's literally all we had to do was just run it, pick that we want to predict risk, know it's a binary classification model, and then save it. I'm gonna go ahead into Designer now. I'm going to pick a data set that's a bunch of new customers or customers that I don't have risk labels for that haven't previously churned. And again, I want to apply that model I've just trained to that data set so I get some risk labels. I'm in the data tab of Designer. Again, you can notice this is all being done in a no-code graphical way, right? I've trained my model. I never touched a piece of code. I just was dragging and dropping onto that canvas. And now that I'm running it, it's the same deal. I'm heading to that Run Models tab. You can see it's listed a few models here that match the input of the data set I'm currently working with. So there was other ones that I trained in the past that actually also were used on this data set and I could apply to this data set. But there's our extreme gradient boosting one that we just trained. I'm dragging it onto the canvas and then it's being applied to my data. And you can see just like that, all I did was drag one thing onto the canvas. I now have a prediction on whether or not they're at risk, as well as a score for that risk, right? One being the highest, zero being the lowest. You can see these that are predicted at churn are above some threshold. In this case, it looks like 0.6-ish. Building on the idea of being able to explain your model though, and if you are giving these insights to downstream users, really making sure it's not a black box, that you can interrogate it, that you can understand why is this person being labeled as at churn, or why is this person being flagged for follow-up. We have a whole explainability tab as well. So what I've done is I've selected an individual customer that was at risk of churn. I've opened this up, and again, I'm doing this within Designer. I can now see what fields, what categories contributed to that churn prediction. So blue means below average. The darker the blue, the more below average. Red means above average. So you see they have a way lower than average revolving balance, lower than average transaction count, lower than average credit utilization. It looks like maybe their recent changes are positive, but it's actually selected each of these columns individually on the right here, and I can perform what if analysis. So if I want to go, okay, what if their, in this case, revolving balance was $2,500 instead of just $70, right? How does that change their modified model outcome? You can see that on the bottom. So they've actually gone from 0.6 to 0.08 now that they have a regular balance. So if this person's balance was much higher, they would no longer fit that sort of risk threshold. And I can do that for every single one individually. I can do it for a combination of them. Again, if their last quarter balance change had changed, in this case, they actually increased, but if it had been the average negative decrease, that might contribute to more risk. And even things like the category of product that they belong to, in this case, a blue card. If I change their card category, right, how is that going to affect their predicted risk, not only on a label, yes or no, but also the actual percentage 0 to 1 risk there. And then I'll just show one more example of opening up an individual customer, again, from our data set and taking a look at this person's also at risk, but for very different reasons, right? Their last quarter balance change was quite low, and their credit utilization, though, was very, very high. So they're actively using their account, but it looks like they maybe had a recent drop, and that's what's causing this risk label. So again, I have so much power there for the end users to sort of understand how the model works, how I came up with these predictions. And now that I'm in Designer, right, these are just two more measures, the predicted probability and the actual predicted label that came from this AI model. I'm now just working with as if it was another measure, right? There's nothing that's different about that. You can see I'm doing the predicted probability. I'm applying a, average calculation to it, and then I'm splitting that up by education. I can create different visualization types. You're familiar with, hopefully, with Designer here and sort of all the power I have in creating these kinds of visualizations. You see there I've changed it to marital status, and then I'll do a couple more modifications, and then we'll do a quick sort of skip to the end result, and what a bit of tinkering, for 15 minutes can get you in terms of a dashboard that can then be, operationalized and consumed by a broader audience. And that's what we're looking at right here. So sort of cooking show style, we've gone from our basic visualization we've created to prettying it up, adding some filters, adding a couple sort of bells and whistles. And now we can look at, we've created this predictive model. What would an actual operational dashboard look like? Again, this is nothing too complicated, but it's something that I think is rock solid in presenting the kind of problem we want to present, which is here's our customer base, who's at risk and why are they at risk, right? So you can see we've taken those bar charts and we've made them horizontal. We've split them by those categories we were looking at before, right? Education, marital status, income category, card type. You see we've highlighted if they're over a certain threshold. So those in, for example, the blue card category are on average 25% of them are at risk. So we've highlighted that in gold. You can see we've applied the corresponding filters on the top, right? So to card category, to income category. Those are all on the top there. And then we've also added a report, right, of individual customers. If we want to drill down to somebody individual, this person's at risk, and that's what we'll be doing here in a second. What are their individual properties, right? And again, this is showcasing broadly the power that designer has in assembling these kinds of pages. But we'll focus on the DSML component and dig into that. So once we've created our dashboard, right, and used all those different components, containers, anything we want to do, filters to create something that we feel comfortable presenting to a broader audience, the only other step here is to save that dashboard and then head into the portal assembly page, right? So here we've got a broader portal with a bunch of different dashboards. We save that dashboard. We're just dragging that onto this canvas as another tab, and then we're good to go, right? So we've gone from training our model, applying it to a new data set, using that new data set with the appended prediction to create some visualizations, assembling those into a dashboard, and then we're in the portal, right? It's as easy as that. So we've gone from again, having a question that we want to answer and just understanding that this is a binary classification problem. Two, a full end result, exploring our customers by their risk, again, on customers we didn't know the risk of previously, in the matter of, 30 minutes to go from start to finish, depending on how good you are at creating these kinds of visualizations in Designer. So once we have this, we have the power to sort of dig deeper into that kind of analysis, right? We saw, I just mentioned, the blue was highlighting gold. More of those customers are at risk. So let's just filter on the blue customers. You can see now everybody's above the threshold, but we can see even more so that those with advanced degrees are even higher on that risk, right? So now we can see it's just showing us those in the blue card category with an advanced degree. And now we've gotten a list here of sort of potentially higher value customers that are at risk that belong to the blue card category. We've sorted in the report by their balance. So now we're looking at those top customers that are at risk, right? And if we pick somebody here, we can actually drill down into them individually. So this person, Armani Sanchez, again, he's a high value customer that has a blue card, an advanced degree that has a really high risk score, right? So then just based off of those same categories, we've applied this individual drill down to look at this person, understand their risk, understand the properties of their account. And then again, if the end result of this is doing some outreach, this makes it so easy to set up that pipeline. There's a couple more visualizations I'm going to talk about, but I'll take a pause here and we'll hop onto the NLQ side of things first before we look at a bunch of sort of different ways you can explore DSML powered dashboards and insights within the portal within Designer.
Yeah, and that's pretty cool. I wonder while you're switching, Ayden, I would be curious. I don't know if we can do a whole question for this, but if I'm curious who all on here is already using some of these things in Designer. I don't if you can hit your raise hand button, I'd be curious. Maybe we can take a quick poll that way. And we'll try to gather the information to get to everybody. But I'm curious who all has already kind of started using some of these and started playing with this feature. Go ahead and go.
Yeah. And
that,
so
able to do that.
Yeah, for sure. The other part I want to highlight is, the DSML services as a whole is not just one offering. It's a bunch of different offerings that all become enabled once you install it. So I really want to highlight how seamlessly those can be integrated, right? We're in that same dashboard. You can see on the left there, the tab we were in was our customer churn dashboard. Now we're at the bottom here in the Ask a Question tab. And what we've done is we've taken NLQ, which is its container, just added it to a page, assemble that in a portal. And now anybody using this that we want to have access to this has the ability to interact directly with NLQ, right? To query data directly. The biggest sort of update to NLQ since its initial version is the move to Microsoft's Phi 3 model, so a really powerful model that understands this business intelligence context, that can be talked to, in a way that people expect now with Gen AI, to really perform not just your simple show me X by Y, but more advanced queries that can filter and can apply measures to and sort of calculate on. So again, a use case for this dashboard might be what we just looked at, right? We're looking at the blue card category, advanced degree people. We know they're at risk. So we've determined that just off of our dashboard, but let's dive a bit deeper. Let's do some of our own analysis using NLQ to maybe create our own visualizations to really explore this problem deeper, right? Why is this category so much at risk compared to, our general customer base? And so this is another example of DSML functionality that's powered by AI under the hood, but you might not notice. This is Instant Insights. If you've heard of that before, again, that's directly embedded within Designer. This is the ability to automatically generate insights, mostly on like correlations, outliers, sort of time series analysis of your data, more on a statistical level to get a good feeling for your data. So we've run that against our data set and generated these kinds of visualizations. To keep it simple, here on the bottom, you can see things like the average months inactive or transaction count really varies depending on whether they're at-risk customer or they're not an at-risk customer. So that's telling us, again, what's important for that model's predictions. And then the last tab here, we'll head back to NLQ. Once we've established what our sort of line of inquiry, we can just begin exploring our data, right? So we'll start with something simple, balance by age, right? We can see there that depending on each of those ages, there's a different balance, right? And I do want to highlight here, we can see there's some spikes, right? Ages maybe like 44 and 56 that, again, our customers in that age range have higher balance. And then I can ask them in different ways too. It doesn't need to be done like a SQL query, right? What is the transaction account for that person we looked at, Armando Sanchez, right? We can see that individually there. These are just examples of reports, but we can dive into visualizations as well. What is the average number of transactions by their income category, right? So if we want to understand maybe how that relates to their income category, we can then sort of put those two together. We know that those high education blue card are at risk, but how does that relate to their account value, to their activity, right? And then we can see risk by age, right? We take a look at transaction amount by age, but we can see there's definitely some spikes, right? 34 there, and it looks like 54. Again, we have a very broad customer base. This might be indicative of some kind of challenge of this age group being more and more at risk. So again, we're going to look a little bit deeper into that, show me predicted risk by name, but then we're going to add a filter to that. So for customers that are 54 years old with a balance greater than 100,000, right? We're applying multiple filters at the same time. So we've taken, in this case, our analysis about their age, and then we're looking at the high value customers. We've combined that all into one query. So we're looking at a measure, a dimension, and we're applying two filters, and it knows tokenized what each of those is asking for. It knows that 54 years old is an age. It understands that that belongs to the age column, that it's going to filter on that. So it might seem like, sometimes we take it for granted as we're interacting with the Gen AI, how it's processing this. But again, I'm not telling it which columns are which. I'm telling it what I want, and it's maintaining the context from the previous queries as well, and determining what columns it needs to filter on, what columns it needs to perform a calculation on, right? So it's done that. And now we've gotten this group here of high value, high account value, 54-year-olds that are at risk, right? And again, balance by their name where their risk is really, really high. So now we're actually NLQ querying against our original model results, right? So against our actual model output. And a couple more examples here. Balance and predicted risk by name, where again, their balance is greater than 100,000, and their risk is very high as well. So we combined those previous two queries into now this list of, it looks like 15 or so customers that are very high value, greatly at risk, belong to this category we've identified of potentially at risk older customers that have blue cards, that have advanced educations. And so through this process of a couple queries, through exploring this in a sort of free form way with NLQ, we've gone from we need to figure out what's causing churn in this category to here's our list of those top 15 customers that, again, if our sort of end goal for this was to perform some kind of personalized outreach, we've now got that right here. We can export that, we can get started. And again, we've just done that in a free form way through NLQ. And I didn't really highlight that, but again, we're jumping back and forth here between report and visualization, right? We've gone from, it can be whatever format makes the most sense by default, but I can manually change that, right? So if I do want to eventually save those visualizations, I like sort of the look of that, I want to add it to a dashboard, I can do that as well. Sometimes it makes sense to view this through a report, sometimes it makes sense to view this through a scatter plot or a bar chart, right? So again, I have a lot of flexibility in the way that I interact with those outputs as well. Okay. And that was sort of a quick operational overview. Again, we didn't cover the nitty-gritty of, what the exact model training looks like, but it's really as simple as that. Again, there's no code involved at any part of the process. It's really just as a recap, what kind of problem am I looking to answer? What category of models does that belong to? Is it a classification problem? Is it a regression problem? I'm just going to drag that onto my canvas. I'm going to select what I want to predict, in this case, risk. I'm going to run that model. It'll automatically save whichever one's performed best, right? And now I have that model as a master file. Again, it can't be opened up directly in Designer, but that's how it's abstracted. That can be shared with the rest of my team, or again, in this case, I can open that up on a new data set, run that model against it, get those predictions, build a dashboard, include NLQ in that dashboard, and all of a sudden I have, a sophisticated dashboard here that both presents all that information, presents all the information about risk, but also gives me the ability to perform, for an end user, their own analysis, their own queries against the data using NLQ.